Alright, as you can tell by the introduction, I'm going to be teaching you how to factor a quadratic in two variables with a leading coefficient greater than 1. Now, if you don't know what that base equation would look like, it looks like this. X squared plus or minus xy, it doesn't matter which one, plus or minus y squared. I use x and y because that's typically what will be used, and it just does not matter what variables. So, we have x squared. Now, there will always be a number in front of that. Whatever that number is, it just depends on the equation. There doesn't necessarily have to be a number in front of xy. Doesn't have to, but there has to be a number in front of y squared. So, now that we know what it should look like, what does it actually look like with an equation? Well, I have a couple of equations here so that we can work through and actually solve together. This equation I have 4x squared minus 9xy minus 9y. So, not 9y squared, my bad. Now that we have that, what do we do with this equation? Now this one is a little more complicated than the two that I have, but it's better to just get this one out of the way quick, don't you think? So, now that we have this, what do we do with this equation actually? Well, first thing that we should do is get rid of the 4x. Now, there are two different ways to do this because 4x can be divided by. That won't leave just... In two different ways, that won't leave one answer being 1. So, we have 4x. I'm not going to fill in the rest because I don't know what that other value would be. So, there's no point because I need to know the sign of it also. 4x, x. And then we have 2x and 2x. So the only way to be able to figure out which one it has to be would be just to solve for both. So, excuse me. Now that we have our two options, what do we do next? Well, we have negative 9y squared, and we need to get rid of that. And by doing that, we need to get factors of negative 9y. And the only factors of that is 9, 1, 3, and 3 with any sign in front of it, positive or negative, but it has to have at least one and the other in both of them. So, now you might be thinking, well, how do we know which one and where? Well, that has to equal negative 9xy. We'll figure out how to, we'll work it together, how to get the y into this equation since we only have x. It'll come later. So, well, how do we do that? Well, the way to do that is multiply the first x by the second y and the first y by the second x. So like that. First y by the first x by the second y, and then first y by the second x. So now that we know how that we have to do that, and then combine like terms and simplify that. So it does matter where we put the sign. So now that we know that, we got to think about this too. What sign we put there? Well, 4x times negative 1 is going to be negative 4, and then x times 9 is just going to be negative 4 minus 9 is just 5. That doesn't work for negative 9xy, so we can cross that combination out the list. So what if we just had 4x plus 9 minus x? That does not work at all. It's nowhere near close. I don't even have to figure that one out. So, let's try the 3's now. We have 4x plus 3, that'll be positive 12, minus negative 3x, that's positive 9. That's kind of close. So let's try this. 4x minus 3, 4x times negative 3 with 3x. So that's going to be negative 12 plus 3x. It's negative 9x. That works. So we can add that. minus 3 for the second coordinates, plus 3 for the first. Now we have our equation. We have our factors, hopefully we do. We don't know for sure yet, because we still have this other one to go to. So we still have to multiply the first x by the second y, and then the second y by the first x, with variables of 9. Well, since it's 2x on both sides, the signs don't matter, because no matter what, it will go to the center. So let's try 9 and 1. Plus 9, 2x plus 9 equals... my bad. Excuse me. 2x plus 9 equals 18 minus 1. That doesn't work, that's positive 17. So let's try 2x negative 9. Well, 2x negative 9, that's negative 18, plus the 1, negative 17. Doesn't work. So what if we try the 3's? 2x plus 3, 2x negative 3. That just cancels each other out, so we know this one cannot work. So 4x plus 3 and x minus 3, that should work. There's always another way to check it, just to be 100% sure. FOIL. First, outer, inner, last. Using that method, we can determine if this truly is the answer. So, we're going to multiply the first by the outer, meaning the x value in the next ordered pair. First, outer, inner. First, outer, inner, last. Simple enough. Alright, so we have 4x times x, which gives us 4x squared. Now we have 4x minus 3, which gives us negative 12. Oh, sorry, I forgot something. Once you figure out what your numbers are for the y's and the x, for the y's and their signs, all you have to do to get in the y is just add y right after it. It's as easy as that. Just add the y as soon as you figure out what numbers you use and what signs you use to go with them for your ordered pairs. So, now that we have that, we have negative 12x, y. So that's first outer. Now let's go inner last. Now we have 3y times x. So we have plus 3xy, because that's what's used in our equation, xy. Now we have 3y minus 3y, so that gives us negative 9 squared. Now we combine like terms. 4x squared minus 9xy minus 9 squared. And look at that. It's the exact same. And that's how you get it with this equation. This was a little bit tougher, but we got it out of the way fast. So now I have another equation. 2x squared plus 7xy minus 15y squared. So we're going to work from the same step. We're just going to add our 2x, because it cannot be divided any other way to make two different sets of factors. We have 2x, don't know the second value, and then we have x. I like to keep the y out of the way at the beginning just to avoid any confusion. That's why I add it towards the middle/end of us solving for this. So we have 2x. Now where do we go from here? Where we're supposed to be getting our factors is negative 15y. So we still got to use the same method. First x times the second y, first y times the second x, to make sure it actually adds up to 7xy. So our values are are 5 and 3, but we have a negative 15, so one of those has to be negative. Well, we don't know which combination, so let's just add in one. We have negative 5 plus 3. Let's try this. So we have 2x plus 3, that gives us 6x minus 5x. That's just x. So that one does not work. So let's make another one. 2x So let's try it the other way. 2x plus 5 minus 3. Let's try that one instead. So we have 2x minus 3. That gives us negative 6y. It's negative 6x, my bad. And then we also have 5x. So plus 5x. Well, that doesn't work. That just gives us negative x. So we need to switch where the 5 and the 3 are. Let's try another set. Let's try another combination. This is more of a trial and error thing until you finally get the one that works. So now we have 2x. Let's try negative 3 this time in its place. Then we have x plus 5. Let's try that instead. So now we have 2x times 5, which turns into 10x. And then we have negative 3x equals 7x, which is our middle term. So now that we have that, we just add y after negative 3 and positive 5. Now we have our values. Hopefully, we can need to always check it. So, we have 2x times x. 2x squared. Then we have 2x times 5y. That gives us 10xy. Now we have negative 9, y, negative 3y and x. That gives us negative 3xy, and then negative 3y plus 5y, which gives us negative 15y squared, because there's two y's combined like terms. 2x squared plus 7xy minus 15y squared. And that gives us our answer. 2x squared plus 7xy minus 15y squared. Well, that was me teaching you about how to factor a quadratic in two variables with a leading coefficient greater than 1. I hope you learned something through this, and thank you for your time.
That's all, folks.